Hello and welcome to the ASP.NET Community Stand-Up. My name is John Galloway. I'm a PM on the .NET community team. And today I'm joined by James Newton-King, and he's going to be telling us all about gRPC in .NET 7.
Thank you.
Yeah.
Excited to talk about it.
And you're joining us all the way from Singapore.
That's right.
That's right. So I'm up slightly earlier and you're up late. And so it's a party. Cool. All right, well, I'm going to jump right into our community links. I don't have a whole bunch today. Let's jump over to there. Cool. All right, so as always, we share these links out multiple ways. Do not fear. They are here. They're going out in the chat, and they're in the description for the video comments. And here we go. All right, so let's start with the first one. And I managed to have picked some long ones this week, so I'm going over them at a high level. So Mike Roussos is talking about upgrading a WCF service to .NET 6 with core WCF. So he had previously written a post about upgrading an app, a bean trader application, and using the upgrade assistant. And 3 years ago, he only got so far in it because it had WCF components in it. And so now he's taking another look at it and using core WCF. So if you haven't used if you haven't used the upgrade assistant, it's pretty neat. I found that I was surprised how much it got done for me in testing some desktop applications and also an ASP.NET MVC application. But so here he's showing going through, runs the upgrade assistant. It walks him through several things, converting SDK and style project and upgrading packages and that sort of stuff, moving to .NET Standard. But then when he's done with all that, he's still got some issues because he's got WCF. And so then he goes through and walks through in here what he needs to do in order to get it going with core WCF. So, and core WCF, we just featured them recently. They just hit 1.0, I believe, and 1.1. There's a new release already coming out, a new bump on that one. So pretty cool what you can get done with that. And Mike, by the way, we also had him on the, we had a modernization Let's Learn event in January, and it was really cool seeing all the stuff he walked through. And he was also on the ASP.NET Community Standup talking about upgrading ASP.NET apps. So he knows what he's talking about. This is a cool one from Joao. He's talking about Microsoft Graph moving to .NET 6. So it's pretty cool that so many things at Microsoft run on .NET and are running, they're moving large applications to the latest version. So they share both, they share all the things, why they did it, how they did it, and what they saw. So he talks about moving, moving up. He talks about the impact here, showing on this graph, the impact in, it's hard to fit everything on there. Let's go with this view, I guess. So here he shows the impact in requests per second and average CPU usage. So that is pretty cool. And then through this also, what I like is talking about, there's a ton in here. It's worth taking some time to actually read through here. But talking about the guidance, updating their build. This is such a common pattern is kind of don't just jump in and start updating immediately. First, kind of get your architecture sorted out, get things set up in a way that you can smoothly migrate. Upgrading dependencies, and then afterwards going through, including things with like A/B testing in the rollout. And then also here's some tips on this, different in like URI encoding, using PGO, et cetera. So very cool stuff.
The great thing about big Microsoft teams taking on .NET 5 and .NET Core and moving their services across is we get to talk quite closely with them, the product team, so ASP.NET Core and .NET, and they'll quite often give us feedback about like where they're seeing performance issues, and then we can take that into account and then roll out a fix for them in the next version, and then also all the customers out there that are using .NET.
Cool. Yeah. It's great seeing there's like this, there's Azure AD. It was cool talking to the YARP team and hearing about how Microsoft's running YARP internally at scale and things like that. And it really does stress test ASP.NET across the board.
And there are so many Microsoft services which are moving to .NET from .NET Framework. So this blog post is great in seeing Azure AD talk about it, but this is just the tip of the iceberg. These are just the teams that have got resources to talk about it publicly.
Yeah.
But it's a big movement within Microsoft modernizing.
Cool. Another similar modernizing one here. This is from February, and I had thought I had shared this before, but I went back through my community links and either I shared it and didn't put it in my community links, or I just didn't share it at all. But so NOP Commerce is a cool commerce solution for .NET. It's been out for a while. It has some neat things including being able to kind of plug into ASP.NET in a different way. Some e-commerce solutions kind of take over your entire application, and NOP Commerce can kind of plug in a way that you can use it in an existing .NET application. So they talk about why they migrated to .NET 6. They talked about performance benchmarks, including significantly faster response time, and actually a small increase in memory usage, although it did go down from 5 to 6. One thing that I definitely see this in applications I've updated, is there's usually a few steps. The first step is just get it working on the newer version, and in general, you'll see better performance. And then the next step is actually taking advantage of some of make sure you're using spans, make sure you're using all these different, opportunities that you have in newer releases. I'm sure you probably see that sort of thing too, James, right? There's you can get running on the newer framework without actually using all those new features.
Yeah, so a big example of that is in .NET 6, we introduced a new way for web apps to configure their startup. So if you choose to, you can get rid of that startup.cs file and put everything in a program CS with a lightweight syntax. But there's no reason you have to do that. So you can take a .NET Core 3.1 app or a .NET 5 app and update it to .NET 6, but just keep happily using startup CS and then migrate across if you want to.
Yeah, cool. And I'm not implying that Knob Commerce didn't already optimize and do great things with this, but I'm just saying it is an opportunity as you're on the newer version. You can continue to profile and benchmark and find even newer things to turn on and newer features you didn't even have available before. So here's showing that, load distribution improving as well. So very cool stuff to see everybody getting on the updates. I feel like too, over time, moving between versions has continued to mostly get easier. I mean, like you said there with like moving, from program and startup and combining those, you don't have to. But so in a lot of cases, as I've updated some apps from 5 to 6, it's a few minutes, unless you're like heavily customizing things.
Yeah, I think it's definitely gotten easier. So going from .NET Core 1 to 2 was a big step because you move from project.json to back to CSproj, and then 2 to 3, at least with ASP.NET Core, is a bit of a jump because we changed the routing system. So we introduced endpoint routing, so there's a bit of a jump there. But since then to .NET 5 and .NET 6, like a lot of apps can just change the framework version and they're good to go.
Yeah, cool. All right, just a few more. Here's one from Andrew Locke. He's troubleshooting why is ASP.NET Core app wasn't working in Docker. So he was testing an ASP.NET Core application on CentOS or CentOS. I always say it wrong. I don't know. I just say both things that pop into my head, so I'm guaranteed to get one of them wrong. So here he kind of walks through. It's nice here to see his troubleshooting technique. So he goes through, runs the application, and then it's not working. It's not coming up. So then he goes through and debugs the issue over here. So, he tests, first of all, looking at the output, checking through the docs, turning on more logging, more explicit logging. And here actually he's seeing the logging is still showing it's hosting. So as soon as I saw what wasn't working, I was like, yep, I've been bit by this too. So there's a difference between loopback and an IP address, a local host IP address or a specific IP address. So here he was, it was the binding, and it was actually binding to the loopback for that machine. When you're testing on your own machine, your loopback is your own machine, so you're good to go. But when you're in Docker, your loopback is actually into the Docker machine, and so it's not getting out of there. And so he showed, fixing that, and then everything worked well. So important to remember both the binding thing and then also just the kind of troubleshooting technique. For me, I've debugged so many things lately where just turning on verbose logging was like, oh, there it is. So that's always a nice feature. I was doing something with scaffolding that wasn't working, and there's an environment variable where you can turn that on for scaffolding, and it showed me exactly what I needed to do. And then lately, GitHub Actions, I've been doing some things and stuff wasn't working, and just making sure every kind of verbose logging was turned on. And so, all right, last one I got here, John Hilton talking about using query string to pass an array of selected values between Blazor pages. What I really liked in here is he talks about and lists out the different ways. There's many different ways you can pass state around in a Blazor app. I kind of think there's like, if you're passing something very simple, you can easily do it with routing. There's state services, and that's immediately what I kind of think of for more complex variables. However, you can pass things as well with deep linking and just a query string, and pass multiple values in a query string. So as an example here, you can have film equals 1, film equals 2, film equals 3. So when you do that, it's just going to pass all three of those things in. And then he talks about binding to that. And he also points out, so you can do get URI with query parameters. But the issue there is that it can only store one value. And so he talks about here .NET 6, and I hadn't seen this before, supply parameter from query in Blazor. And this will allow working with multiple things. So yeah, definitely the navigation manager is kind of what I had thought of, but it's nice to see also that you can use this binding to multiple parameters in a query string as well. And that's all I got. I've shared the links a few times in the chat, so you should see those. And if not, they're here. They're also in the description on YouTube. And with that, James, I'm going to turn it back over to you. So you're going to be talking about grpc in .NET 7.
Yes. So one feature in particular, I've got some slides shared. If you could bring up second screen. Great. So big new feature in .NET 7 with grpc is this feature called grpc-JSON transcoding, and we'll talk about it today. So for anyone who is unfamiliar with grpc, I think I've reused this slide about 5 times now. So it's a popular open source remote procedure call framework, and RPC frameworks make it easy for apps to talk to each other. grpc is run by the Cloud Native Computing Foundation, aka the CNCF, and Microsoft is contributing to the CNCF this grpc implementation, and we're working together with them to make grpc really great on .NET. It's supported by every major programming language, so there are implementations for C++ and Java and Go, Node, Ruby, C#, Rust, you name it, there is a grpc implementation for it, and all of these can talk to each other. So C# can call C++, C++ can call Java, etc., etc. grpc is contract first, so messages and methods are defined in a contract, and that is then used to drive code generation. So we'll look at that quite a bit later. grpc is not new, it was open source in 2015, but it's built using modern technologies. So for its transport protocol, it uses HTTP2, and now also HTTP3 if available, and it uses Protobuf as a serialization technology, and also for the contracts definition. Okay, so let's build a basic grpc app for anyone who hasn't seen it before. So inside Visual Studio, we have a template. Well, inside .NET, we have a template for grpc. So I'll just select it over here since I've already got it. This will create an ASP.NET Core website with a grpc Hello World service already set up. And we're going to choose .NET 7 because this new feature requires .NET 7. So we'll create this, and Visual Studio will launch up, and let's take a quick look at what we have in our Solution Explorer. So we've got our greet.proto, so this is where our contract lives. We've got greeter service, so this is an implementation of our contract, and then we've got the standard app settings and program CS. So taking a look at our greet.proto, this is a language-neutral syntax for defining a protobuf and grpc service definition. So starting at the top, we've got a greeter service with a say hello method. So you can think of a service like a controller, an MVC, and a grpc method like an action. So our say hello method takes a hello request, which is a message which has a string field on it called name, and it returns hello reply. And hello reply has got a property on it called message, which is also a string. So basically, we've got hello world here. We're sending a name to the server, we're getting back a response with a message. Now let's take a look at our service, our implementation of this service. So we've got a greeter service that inherits from greeter base. We've got some dependency injection here of a logger. We don't actually need this, so we'll just get rid of it. And then we've got a say hello method. So this is our implementation of our contract. We're just getting the name from a request. We're setting that onto a message, and we're returning it. So looking at this, something which jumps out to you straight away are where are these types coming from? Where is greeter base coming from? Hello reply, hello request. And the answer is code generation. So if we F12 into this, we can see we've got a whole bunch of kind of ugly code. And at the top, we can see we've got a notification that this has been generated from the greet.proto file we looked at earlier. But fortunately, code generation is writing this so you don't have to. All you need to know is there is a greeter base type that's abstract, and it's got a say hello method on it, which by default will throw an unimplemented exception. So all which is happening in our actual implementation is we're inheriting from this, we're overriding our say hello method, and we're doing some stuff. And we can see
the code generation, that's MS Build, like that's not using the kind of newer code generators, is it? Right?
No, it's not using Roslyn code generation. It's actually using behind the scenes a tool called Proto-C. So it stands for Proto Compiler. So it's actually a exe which ships in a NuGet package and MS Build invokes. So I'll talk a little bit about that in a second. But basically it means we can come along and modify our server. So let's add say hello new, save that. And then if we come along to greeter service, we do override, we can see say hello new showing up, and we can very quickly interact with it. So when I saved this proto file, MS Build just invoked the Protobuf compiler behind the scenes. The giant CS file got updated, so we can see we've now got say hello new down here, and we can just keep on coding. So the way it actually works behind the scenes isn't that important. You just need to know that you can very easily modify and add new members here and have code generation do a lot of the work for you. So that's that. Let me just compile this to double check it works. All right, so let me come in and we'll run our new grpc service. So if I call .NET run, this will launch up Kestrel. Our grpc service just lives inside Kestrel, and we'll browse to this endpoint, and we get this message, and it says communication with grpc endpoints must be made through a grpc client, which kind of makes sense because we don't have our client, in this case the browser, doesn't know about that contract. It doesn't know how to talk grpc, it just knows how to do HTTP, so we need to create a client to talk to our service. So to do that, we'll create a new project. We'll just create a console app for our client. Click create, and let me just copy and paste our proto file across. So we've got our console app writing hello world to the console, helpfully. We need to do a couple of things here. We need to add some NuGet packages. So if we take a look in our grpc service, we can see we've got a package reference to grpc.ASP.NET Core. This is bringing in tooling. And also we've got this protobuf reference to greet.proto. So this is how we register our proto file with tooling, so that when it runs, it will automatically generate C# code for this greet.proto. So we need to set up the same system in our console app. It's pretty simple. We just right-click on our console app, which is add, then add a service reference. And a service reference is basically the client application referencing a service for calling it. So we could have open API. So this is your swashbuckle file. You could have WCF. So if you're using core WCF, you've got that WSDL file, you would point your service reference to that. In the case of gRPC, we're just going to point towards that file, which is sitting on disk. So we'll just browse that protos file, choose greet.proto. Then we want to choose the type of code we want to generate. So by default, it will select a client for us. We've got a couple of options on the server. We were generating server code because we want a server space type. On the client, we want a strongly typed client. So we'll just leave it selected in client. Click finish.
One neat thing there, you showed loading a proto from a file, but also you can load from a service, right? So if you're like connecting to a published gRPC service, you can just point it at the URL.
Yeah, you'll point it at the URL and it will download it locally for you and just do that extra step. It's a little different from WSDL, where I think WSDL is sort of the pointing to a remote location was sort of the default behavior, just because to generate that WSDL file with WCF, you really needed the app running, just because you wouldn't really write a WSDL file manually, then save it to disk. While proto files, they're designed for humans to read and write. It's quite an easy syntax. So usually you'll have that sitting on disk and you'll just point to a proto file on disk. So a bunch of things happened when we added our service reference. We added some NuGet packages, and then we added the service reference to the actual greet.proto. So if we take a look at the CSproj, we can now see, just remove that guy. We can now see we've got a protobuf element, we're referencing greet.proto, we're generating client services rather than server, and we've got NuGet packages. So let me just build this, double check everything's still working. Okay, so we've set up tooling, we've set up our contract. Now to actually call our service, we'll create a channel. So you can think of a channel as the representation of a connection between the client and the server. So we'll create a channel for an address. So in this case, we want to specify our server address. And when we ran our server earlier, we got the port on localhost. So we'll just copy and paste that and use it here. And then we'll create our client. So our client has been a strongly typed client that's been generated from that proto file. So we type greeter and then greet client channel. So this is a strongly typed client that was created from that proto file. So because we've selected client down here, we have this client here, and if we F12 into it, again, we'll see a whole bunch of code that's been generated for us. It all looks pretty ugly, which is why we have code generation write it for us rather than us do it manually.
Quick question, so this came in on chat, but I was wondering this as well. So you've shown kind of copying a file between two projects. Is that kind of the standard way you do that? Is there a way to kind of share that, or?
You can certainly share it. So actually sharing happens by default when you use the service reference. I've copied it only because I'm going to be modifying this greet.proto on the server to add some new concepts. And I just don't want to have to worry about dealing with those changes in the client when they're linked together, just for the purposes of this demo. I think if you were doing this properly, you would have your proto files located in a different directory, and both the console app and the server app would both sort of have a link to them. So when you reference files in a CSproj file, you have the option to do a linking operation rather than copying if you want to reference them somewhere out of the directory. And I'm just not doing that just as a shortcut for the purposes of this demo.
Okay.
All right, so making our call. So we've got our client, we've got our channel, we've got code generation. All we need to do is invoke our method. And to do that, we just call say hello async. And because everything's nicely, strongly typed and code generated, we can just say .NET Standup and then write out the reply. Cool. So I'm going to just compile this, double check. So if everything has gone to plan, we should see from server, hello, .NET Standup. So what just happened, our client app connected to the server using this address. We created a strongly typed client, we invoked it, and we wrote out the response. And we can see that's happening on the server by just logging a bit more. So if we change our warning filter to an information filter and restart our server and invoke our client again, we can see over on the server side, we've got our requests coming in. So we've got a HTTP2, it's a post. The URL is this greet.greeter/say-hello. So this is sort of a standardized URL which has come from our package name, our service name, and our method name. And then that gets mapped to a endpoint using routing and executes, it returns, and we get this value back in the client. Okay, so that's a very basic gRPC application.
We've got two quick questions that came in before I let you show off the new stuff.
Yeah.
Okay, so Dick's asking, how should we think about gRPC versus SignalR? Yeah, so what do you think?
So SignalR has great support for running in browsers, while gRPC doesn't. So if your main use case is running in a browser, then you should probably consider SignalR. Now, both gRPC and SignalR support streaming and real-time streaming. The difference is SignalR has a lot of functionality in the server to broadcast messages out. So what I mean by that is you can have a whole bunch of browsers connect to a server, and the server knows about all those clients, and any one of those clients could send a message to a server, and then that server could decide to broadcast a response out to all the clients. So you could imagine a chat room, all these SignalR clients sitting in a chat room. One of the clients sends a message to the server, and the server decides, okay, this is a chat message, let me broadcast it out to all the other clients so that everyone else in the browser chat room will see the message. Now, you can certainly replicate that behavior using gRPC, but it requires extra work. It requires the legwork to handle keeping track of all the gRPC clients. It requires the legwork to broadcast the message out. You can certainly do it. It's just more work, and SignalR has that functionality built into it.
Okay. All right. One other question here. Can the browser deconstruct a protobuf message and show it in human readable form? And I feel like this is kind of actually going forward towards what you're going to be talking about next slightly.
It actually isn't. What I'm going to be showing will happen all on the server.
Okay.
The answer is yes. So
okay.
You can use this technology called gRPC Web to make gRPC calls using Protobuf from a browser. And what you can then do is, once you've got the Protobuf message back and it's been deserialized into just JavaScript objects, you can just call stringify on that, and you could turn your deserialized Protobuf back into JSON and then display it if you want.
Okay.
So you can certainly do that.
Cool.
But we will be talking about Protobuf and JSON and how they work together quite a bit in the over the next 10, 20 minutes.
Okay.
So sort of summarizing what we just saw, fundamentally gRPC is another way for apps to talk to each other. So a client calls a server with a request, it gets a response. This is really no different to the way a REST API would work. The first difference is gRPC requires HTTP2 or greater, and it uses Protobuf messages as a payload instead of JSON. So the bigger difference is in how gRPC apps are written. As contract first, we've got that proto file that we saw, our messages and services are defined there. So from that proto file, we have a service-based type generated using tooling, and then a strongly typed client generated tooling, and everything is great. So like all technology choices, there are trade-offs. gRPC isn't strictly better than REST, and as we just covered in that question earlier, it's not strictly better than SignalR. There are pros and cons. So let's discuss some of those. HTTP2 is great. It allows us to do multiplexing. That means we can send multiple requests in parallel over a single TCP connection without them interfering with each other. And also it enables advanced real-time streaming. So you can use that advanced real-time streaming to replicate a lot of what SignalR provides, just minus that broadcasting functionality. The downside is HTTP2 isn't supported everywhere, so most notably in browsers. So while a browser can obviously use HTTP2 when you're viewing a web page and is downloading images, the client in a browser, so the low-level JavaScript APIs like fetch and XML HTTP requests, they don't have access to low-level HTTP2 features, and for that reason, you can't build a fully compliant gRPC client in JavaScript. You have to use an alternative technology like gRPC Web, but I'm not going to talk about that today. Protobuf compared to JSON. Protobuf is high performance, it's small, it's fast, it's binary, it's designed for computers to read and write, not people. You can deserialize it very quickly with less CPU compared to something like JSON, XML, pretty much any text-based format. The downside is because Protobuf is binary, it's not human readable, and it also requires the proto file to decode. So you really need tooling to be able to debug Protobuf. And then this contract first way of doing development is really great for productivity. You can just update that proto file in one place, then tooling throughout your stack will generate all your messages, your service-based type, your strongly typed client. You don't need to worry about routing or serialization or HTTP headers. All of that stuff is handled for you. And you don't need to worry about your client and your server going out of sync. The downside is you need to learn that proto syntax. It's not very difficult, and we have great documentation to help you understand it and learn it. And then you also need to set up tooling. But as we saw in that demo earlier, it's quite simple with .NET. It's just a matter of referencing the right NuGet package, adding Protobuf elements to your project file, and you're good to go. So there are trade-offs here. Wouldn't it be great if we could have both? I think there are a lot of situations where people want to have a gRPC service because they want to talk between different servers in a very high performance way. But then they also want to be able to call those services perhaps from a client, a browser, just using JavaScript, or they just want to provide both options. So they give customers the option of performance or the option of getting started very quickly and easily using a REST-based API. So introducing grpc JSON transcoding for .NET. So what this technology is a NuGet package that extends .NET gRPC functionality and allows you to automatically generate RESTful services from gRPC. Now this functionality has actually been available for a couple of years now as an experiment. I was calling it grpc HTTP API. I decided to rename it because the first time I gave a talk about it, I realized how many letters there are every time you say grpc HTTP API. And after saying that over and over for an hour, I went insane. So it's now called grpc JSON transcoding. So there's been a lot of interest over the last couple of years from internal and external users of .NET, so both within Microsoft teams building very large services, and also external customers also building some quite large applications. So in .NET 7, we're turning that grpc HTTP API experiment into a part of ASP.NET Core. So how does this thing work? How can you just suddenly have grpc start talking JSON REST? So let's add that functionality to the app we just made. So first thing we want to do is in our server CS_proj file, we want to add a package reference. So this is a new package. It's going to ship with .NET 7 Preview 4, which should be coming very soon. And that's the first thing we'll do. The second thing is we're going to add some configuration at startup. So we've got our add grpc call to add grpc services. We're now going to call add JSON transcoding. It just hangs off add grpc. The next thing we want to do is we're going to add some proto files to our server. So I just added 2 proto files, annotations.proto and http.proto. They live under this Google folder /API, and then they're located here. This is kind of annoying having to do this step. I'm going to investigate whether we can find a way to automate adding these for you, or maybe you don't even need to add them or see them at all. But for now, we need to add these 2 files to our server. And then finally, we're going to annotate our contract so it knows how to talk HTTP and JSON. The first thing we'll do is we'll add an import, and this import will point towards this annotations file we just added. So, oops. These 2, and you'll notice the path is the same. So Google/API/annotations, that matches up over here. So that's step 1, and then step 2 is we're going to add an annotation to our say hello method. And we'll comment the old one out. So the actual grpc part is exactly the same. We've still got an RPC of say hello. We're taking a hello request, we're returning a hello reply. All we're doing is we're adding an annotation. So you can think of an annotation like an attribute in .NET that you add to a method. We're just adding metadata about how this method works. In this case, we're adding what's known as an HTTP rule. And our HTTP rule, like an attribute in .NET, you can specify parameters on it. In this case, we're specifying a get parameter, and we're specifying a route. So v1/greeter, and then this name binding. And if we compile this now, just to double check everything's still working, I might need to stop this app. It's build succeeded. So if I now run this app again, if I wanted, I can still call it using grpc. So .NET run, we just had our grpc call come in. Again, we can see we've got an HTTP2 post to our standard grpc endpoint. But now, if we want, we can browse to it using that RESTful route. So let me drag this down here. So we've got v1, greeter, and let's say, hello, John. Boom. So we just called our grpc endpoint using a RESTful URI, and we returned JSON. And we did that without having to recreate everything in MVC or define minimal API. We still just have grpc, we still just have one greeter service, and we're still executing this. And we can see that in our logs. So if we take a look down here, so earlier we had our gRPC call. And down here, you can see, no, that's not it. Down here, you can see our RESTful call. So this one happened to be HTTP2 just because our browser decided to do HTTP2, but now it's a GET, and we've got v1 and greeter John.
So there was this response that came in here, and I think this is important to clarify. You haven't converted your original gRPC call to use JSON. Like, you haven't moved your original gRPC call from Protobuf to JSON. You're just exposing this service in two different ways, correct?
Exactly.
Okay.
That's exactly the way it works conceptually. So we still have one service where we now just have two endpoints for calling it. We have our gRPC endpoint, and by specifying a bit of metadata on our proto file, JSON transcoding and the functionality that we registered here, it now knows to take a look at our proto file, see whether we've got this annotation, and if this annotation exists, now we just happen to have a new endpoint that accepts JSON and returns JSON instead of Protobuf.
As you're showing there too, that's in the proto file. So this is not just a Microsoft.NET thing. This is part of the proto spec, right?
Yeah, I'll talk about how this compares to the overall ecosystem. So this, you can think of it kind of like this is an implementation of this concept. There are other implementations, but this particular one is tied to .NET just because it runs inside the .NET process. But I'll talk more about what that means in like 5-10 minutes.
Okay, I got one more question before I let you get back into this. So Lola said they have tried doing this sort of thing and they ran into CORS issues. Is there anything CORS specific that you would see here, or would the guidance just be the standard kind of ASP.NET CORS stuff?
It would be the standard ASP.NET CORS stuff. So
okay.
Your application, it's just an ASP.NET Core application. It's got gRPC as usual. It's got an endpoint as usual. It's talking, that endpoint is talking JSON. You can call it from a browser. You can configure cores on it as usual. The fact that Minimal API would be exposing the endpoint versus MVC exposing it versus JSON transcoding exposing it doesn't really matter. If you configure cores, the browser's just going to use it and it will be callable. It'll just open up the possibility that cores allows of making cross-domain calls.
Okay. One other question that came in here. So what you're showing is .NET 7. There's no real way to use this in .NET 6, correct?
Correct. Okay. Yeah. So this uses features that are only going to be available in .NET 7, specifically around how we do JSON serialization. So it's not something you see publicly, but to efficiently serialize JSON, some new features are getting added to the serializer, and we're going to use those features in JSON transcoding.
Okay.
Cool. So coming back to a high-level diagram of what just happened, we've got our client, which is gRPC. We've got our server, which is ASP.NET Core. We've got our, obviously, exposing a gRPC endpoint. So to invoke that, you would specify the URL of greet.greeter, say hello. Is talking HTTP2, it's talking Protobuf. It maps to an endpoint using endpoint routing that just validates that it's a proper gRPC request. A serializer called google.protobuf will deserialize it, the incoming protobuf to hello reply. It will then invoke the service. The service will return, it'll deserialize hello request, or will invoke the service with hello request. The service will then return hello reply. That will get serialized, will get returned in response. All good. As we mentioned earlier, when we talk REST, it's really just another endpoint. It's calling into the same service. We're not duplicating anything. It's just another view of the same service. And by using that annotation, we're able to specify how our HTTP and JSON maps to gRPC. So how does all this wizardry work? So we mentioned earlier, like, can you make Protobuf visible as JSON? That concept is built into Protobuf, and we're leveraging it with grpc JSON transcoding. So there's a standard mapping between how you represent Protobuf and how you represent JSON. And this is actually built into the spec. So using these rules, we're able to translate Protobuf to and from JSON as it's coming in and out of our service. So those rules are actually pretty idiomatic. Our message, so hello request and hello reply, that's sort of like the standard building block of gRPC, and is serialized as a JSON object. The fields on the message is the name, and then the value is the value in the JSON object. You can have repeated fields. That's like list collections. Those are serialized as a JSON array. Map fields, you can think of those as dictionary collections. Those are serialized as a JSON object with the key as the name, and then the value is the value. Enums are serialized as strings by default, although there is an option to serialize as an integer. And then all the other types are generally serialized as you'd expect. A string is a string, a boolean is a boolean, and so on. The one exception, which you might see in this list, second from the bottom, is 64-bit numbers. So the spec, the Protobuf spec, says those should be serialized as strings. Now, the reason they chose to do this is JavaScript only supports up to 52 bits of precision with their numbers, which means if you're serializing a very large or very small number, say int64.max value, JavaScript isn't going to be able to represent that completely. So for that reason, the Protobuf spec says you should write 64-bit values as strings. I'm not a huge fan of this. I don't think it's what people would expect by default. It isn't what .NET serializers do by default. And you only really encounter this problem if you are using JavaScript and you do have a 64-bit number, and it is a very big number. So for that reason, .NET JSON transcoding writes those 64-bit values as numbers by default, and then it has an option to write as string if you want it. The second part is the mapping of HTTP to gRPC that we saw in that proto file using an annotation. By default, all gRPC methods are a post with that standardized URL we saw, which is the package name, then the service name, then the method name, and then the messages, the request message is posted as Protobuf in the body, and the response is returned in the body. Adding annotations to the proto file lets us customize the HTTP method, the URL path, route binding, response JSON, and more. So in the demo app that we saw earlier, we have our say hello method, which has an annotation on it. It has a get route. So we have get, then we're specifying the route. That's how we expose it. The name property in our hello request has been bound from the name segment and the route. So in this case, that final slash specifies the name. So there are a bunch of options about how you populate incoming request values. They can come from a JSON body. They can come from a route segment. They can even come from a query string if you want to specify values like that. And then finally, the hello reply with its message property, message field, that's just serialized as JSON. So we saw earlier in how Protobuf matches up to JSON. This is a message, so the field is just serialized as a JSON message. Continuing to show a different example, this time of a post. So you're not limited to just get. We've got now our say hello from method. We've got hello request from message. And here we're specifying a post and then a route. And we've also got this extra property, bit of metadata called body. And that star value is just saying all of the body should be bound to the request message. So that means our hello request from message is being bound from all the JSON which comes in from the body. In this case, we've got name world from .NET. That will then get passed to our service method. And then when you eventually serialize the reply, again, it will just get serialized to JSON. So those two concepts allow us to map pretty much, well, not, I wouldn't say any message, RESTful message to gRPC, but probably the vast majority of messages and concepts you want, like a combination between route binding and JSON message binding, you're able to create a pretty idiomatic RESTful API just using your JSON calls without having to duplicate everything. So JSON transcoding that I presented here, it isn't actually a new idea. There have been other technologies like grpc-gateway and Envoy, which are both kind of reverse proxies that have supported this feature for a couple of years. The features that they support are very similar. So you still use those same JSON protobuf rules for mapping between the two. You use the same annotations. The key difference is really how they're implemented compared to JSON transcoding and .NET. So they are implemented as a proxy. So the way that works is your client, starting at the top of this diagram, will send a RESTful API call to the server. A reverse proxy would intercept that. It would decode the incoming RESTful API using that proto contract. It would turn it into a gRPC call, and then it would actually make a gRPC call over HTTP2 to a different server. And that server is where you would have your logic with your gRPC service. So there are pros and cons of that compared to JSON transcoding and .NET, which runs in process. The pros with Envoy and grpc-gateway is it works with any server implementation. You could have a C++ server sitting behind this, a Java proxy, a gRPC server, a C# server if you want. It doesn't really matter just because it's a gRPC call which is coming into it. Meanwhile, with JSON transcoding and .NET, they run in the same process. They're intrinsically tied together. You have to use .NET. But the downsides with what grpc-gateway and Envoy are doing is you have an extra app you have to worry about. So you've got this reverse proxy you need to maintain and keep up and have resources for, maybe like it's running in its own container. So you've got to dedicate CPU to it. So it costs more. And then there's the overhead of the gRPC call. It's a lot more expensive to create a new gRPC call and send it over HTTP2, and then have the server receive that gRPC call and then process it. I mean, the whole process happens in reverse. Meanwhile, JSON transcoding and .NET, that's just in process. It's just a matter of calling a method using the object we've deserialized from the request. So it's very cheap. So how does JSON transcoding compare to MVC or Minimal APIs? Because it's just another way of doing JSON if you want to take a look at it from that point of view. So JSON transcoding is designed to be a fast, easy way to expose gRPC services as RESTful APIs without duplication. If you're not using gRPC, it doesn't really make sense to use it. So that's step one in figuring out whether it's the right fit for you. Another limitation of it, and there are many limitations in JSON transcoding, and that's by design, is unsurprisingly, it only supports JSON. If you want to have an API that also is doing message pack or XML for some weird reason, this isn't the right technology for you. This is about exposing your gRPC services as JSON, not any language you want. Another thing is you can't you don't have a lot of control over the way JSON is serialized. With system text JSON or Unionsoft.json, you can define all kinds of settings to customize how you want JSON represented. You can change how fields are, or property names, the casing, like you can have camel casing or snake casing or Pascal casing. You can register JSON converters and completely take over how objects are serialized. You don't have that capability here. Pretty much, you need to follow those rules. And then if you want to use advanced routing features like route constraints or route policies, you don't have the ability to use those with JSON transcoding. So really summarizing, if you want exact control over every part of HTTP requests coming into your server and going out, and with your API, then probably MVC or minimal APIs are a better choice.
So it feels like if you want to write, if you're primarily building a RESTful web service, then you don't want to do this. But if you're writing a gRPC service and you want to turn on, you want to be able to connect to it, over REST and work with it in JSON. To me, the like a main thing that lights up for me is if I'm mostly serving a gRP service, but I want to be able to debug it and kind of, you know what I mean, and kind of work with it as a developer. This lights up some nice things for me too.
Yeah, there are, saying that there are good tools around interacting and developing with gRPC without having to use REST. So in our documentation, we talk about gRPC curl and gRPC UI. That basically emulates the Swagger UI that you see over OpenAPI. So you can generate OpenAPI, then you have that Swagger UI, and you can sort of interact with services from the browser. There's the exact same tool, or a very similar tool for gRPC. So if you want to do ad hoc testing of your gRPC APIs, you can do that using just gRPC tech. But I think you are right that if you're not using gRPC, then it doesn't make sense using this. If you want exact control, then you probably still want to keep using minimal APIs. But if you want a turnkey solution to get pretty good RESTful APIs within half an hour, so you can imagine it takes 5 minutes to set up JSON transcoding and then another 20 minutes to annotate all your APIs, and then suddenly your gRPC service is also talking REST. That's a pretty good deal. In saying that this isn't a binary choice, you can actually mix and match JSON transcoding with minimal API or MVC. So you could choose just not to annotate a particular gRPC service and instead register a minimal API for that particular one and just use minimal API just because perhaps you want to have greater control. You want to do something weird with the JSON, or you want to do some additional validation of HTTP headers, for example. So it's not a binary choice. You can choose to have a mix. Okay.
All right. Makes sense.
And that's it for gRPC JSON transcoding. So if you're interested in learning more about gRPC, there's a whole bunch of documentation. So if you visit docs.microsoft.com, there's an introductory tutorial, which pretty much follows what I did when I created that Hello World app at the start of the talk. And then a whole bunch of other things which we haven't discussed today. And then a whole bunch of examples. And one of those examples, I don't think it's quite merged yet. A PR is saying to get merged at the moment, is a demo of how to run gRPC JSON transcoding.
Okay. And you earlier showed a screenshot. You've got a blog post on this JSON transcoding that's due out, I think today or tomorrow. It's due out very soon.
I think it's tomorrow.
Okay.
But it's coming very soon.
Yeah.
So I'm not 100% sure whether this functionality in Preview 4 is out quite yet. I think Preview 4 is coming out very, very soon. If it isn't available right now, you can take a look at the experiment in the meantime. So the experiment was grpc HTTP API. So this is a test website I set up on Azure a couple of years ago, which shows it off. And you can actually use this to invoke the services. So here we're I've got a gRPC service hosted on the server, but I've also got transcoding set up as well. So I've set up some UI to call it, and likewise, if you want to do a post, so hello world from .NET Standup. You can see down here we got our post and we got our response, all JSON all the time. And this demo, this website also shows off generating Open API from our grpc JSON transcoding. So you can actually use Swagger to then invoke grpc, which is kind of a weird thing to do.
Nice. Yeah, so there actually was a question on that. You mentioned Swagger. So like, is that something where you can turn on Swagger for your JSON endpoints when you're using gRPC transcoding?
So the idea is yes, you will be able to. In Preview 4, that isn't available, so that's not going to be available straight away. Ironically, this is going to be a feature the experiment has that the final version doesn't have, at least for a short amount of time. So we're planning to make Swashbuckle and Open API support available later in .NET 7. At the very least, when .NET 7 releases, it will be available as a preview. We're just considering the best way to do it. The way the experiment did it was it took a hard dependency on Swashbuckle, and we're just considering whether it might be a way to support it without that dependency.
Okay. Another question here. You're showing an Azure website site. I know there were issues earlier on with gRPC on app service because of the HTTP2 support. What's kind of the current status there?
So with Azure App Service, it hasn't yet been resolved. I think progress is being made, and it should hopefully get resolved soon. In the meantime, there are alternatives in Azure that do support gRPC. So I think it's like Container App Services. Is that the name of the new service? It's the one which has really great support for Dapper. That service does support gRPC. Okay.
Was there a thing? I think I remember using app service on Linux. Did that? I forget if that worked.
So let me just go to the documentation. So the documentation currently talks about the older version. So if you're interested in learning more, you can, at least for the next couple of days, play around with the older version, and it works exactly the same way. The only real difference is the package name is different. But let me go to supported platforms. Yeah, so Azure Container Apps. So this one does support gRPC over HTTP2. If you want to use Azure App Service, you can, but you need to use gRPC Web.
Got it. Okay. What about, while you're on this page, will this work fine with IIS?
I haven't tested it, but it should do, yes. I'm pretty sure. Like, there's nothing where I can think about that would cause this not to work with HTTPS, with IIS or HTTPSys. Okay. So I've tested it with Kestrel, I've tested it with Test Server. If IIS or HTTPSys don't work, then log an issue and we can look at it before .NET 7 ships.
Okay,
Cool. We certainly want it to support IIS.
So one thing that Lalo noticed was that you were showing using, it's the same port. So you've got your gRPC and JSON both running on the same port. And yeah. Is that magic working just because one's HTTP2 and the other is not?
So the port doesn't matter in this case because it supports both HTTP1 and HTTP2. And the client will just use a technology called protocol negotiation to decide which one it wants to use. So in this case, we're using HTTP2 both for our GET and our POST. And it doesn't really matter. So this one is the proper gRPC call because we can see applications whack gRPC down here. The short answer is it doesn't matter. And REST will work over HTTP2 or over HTTP1. It doesn't care. gRPC requires HTTP2. A client will really negotiate which one it prefers. So if we wanted to, we could use a different port for our client. So E1 greater. Okay, so the reason I'm getting that message is because in our service, we've configured that HTTP2 is always required. But if we got rid of this, we didn't specify that HTTP2 is required. Let's stop our app and restart it. So this now works. And if we look at the logs, we can see we're doing HTTP 1.1. And now if we change this to use HTTPS, and I forgot the port number. So this request also works. Right. This one's using HTTP2. So REST doesn't care.
Yeah, the thing REST, I wasn't noticing, and GPNL points out here, there's different endpoints here. That's how it's. So it's yeah.
Yeah, it's different endpoints, but the same port. And gRPC doesn't require its own port. It can happily coexist on the same port as other HTTP2 traffic. You just need to be able to call that port with HTTP2. So the one case, we wouldn't be able to call HTTP2 on this 1.1 port that isn't using TLS because it's not using TLS. And as I'm making it sound very complicated because it is actually quite complicated, but I think I'll just summarize it as REST works everywhere. It works on HTTP 1.1 and pretty much every server talks HTTP 1.1 and you can happily coexist on the same ports.
Great. Okay. That's about all the questions. So you had showed some links and some kind of where to go next sort of stuff. And then you've got your blog post coming out on the .NET blogs, and I'll add that to the links here. So.
Yeah, I think a place you can go if you just want to see the current experiment working is grpc http api.azurewebsites.net, and this is using the older version and it links to documentation about the older version, but it works exactly the same way. Really, the only difference is the package name is different and the method you call and the application startup is different.
Okay. Very cool. Wow. Well, this is neat. And so then there's stuff we can start looking at today. You've got the blog post coming out, and then this is will be released coming up in .NET 7.
Yeah.
Very cool. All right. Anything else you'd like to say as we wrap up?
I think I need to come back to ASP.NET Standup because I don't think we ever actually talked about the features that we added in .NET 6. I think I was so busy adding new features and adding HTTP3 to Kestrel, which I I think we probably need to talk about as well. So I think I need to book coming back again.
Sounds great. Okay. Well, let's do that soon. I'll bug you about that, and then we'll get it scheduled. I'll keep you up late again. All right. Okay. Well, thanks a lot, everyone, for watching. Thanks for showing off all this great new stuff, James. And we'll catch you again soon for that follow-up show.
Yeah, it's great.
All right.
See ya.
Thanks, folks. Bye.